Hi, welcome back. In this class, we'll be learning of more complex decision-making statements. First, let us see the forms of if statements. If this condition is true, then do this. The second form is if this condition is true, then do this and this, basically multiple execution statements. The third type is if this condition is true, then do this. If it's not true, do this. Fourth type is, if this condition is true, do these two, otherwise do these. The fifth type is, if this condition is true, do this, else check if this condition is true and do this. If this condition is not true, then go to this execution. Sixth type is, check for this condition. If this condition is true, then check for this condition and do this. If this condition is not true, then do this and this. If this first if condition is not true, then do this. Use of logical operators. C allows usage of three logical operators, namely AND, OR, and NOT. The symbol for AND is double ampersand, the symbol for OR is double pipe, and the symbol for NOT is an exclamatory mark. These are to be read as AND, OR, and NOT respectively. There are several things to note about these logical operators. Most obviously, two of them are composed of double symbols, that is, a double pipe and a double ampersand, which refers to OR and AND. Don't use a single symbol of OR and NOT, that is a single pipe or a single ampersand, because these single symbols also have a meaning. These are bitwise operators. The first two operators, AND and OR, allow two or more conditions to be combined in an if statement. Let us see how they are used in a program. The problem statement of the first program is, the marks obtained by a student in 5 different subjects are input through the keyboard. The student gets the division as per the following rules. Percentage above or equal to 60 is first division. Percentage between 50 to 59 is second division. Percentage between 40 to 49 is third division. Percentage less than 40 is fail. Write a program to calculate the division obtained by the student. So this is the code. This is a straightforward program. Observe that the program uses nested if-elses. This leads to three disadvantages. As the number of conditions go on increasing, the level of indentation also goes on increasing. As a result, the whole program creeps to the right. Care needs to be exercised to match the corresponding ifs and elses. Care needs to be exercised to match the corresponding pair of braces. All these three problems can be eliminated by usage of logical operators. The following next code can eliminate all the three mentioned problems. So this is the second method of writing the code. As it can be seen from the second if statement, the AND operator is used to combine two conditions. Second division gets printed if both the conditions evaluated true. If one of the conditions evaluated to false, then the whole thing is treated as false. Two distinct advantages can be cited in favor of this program. The matching of the ifs with their corresponding elses gets avoided since there are no elses in this program. In spite of using several conditions, the program doesn't creep to the right. In the previous program, the statements went on creeping to the right. This effect becomes more pronounced as the number of conditions go on increasing. This would make the task of matching the ifs with their corresponding elses and matching of the opening and closing braces much more difficult. There's one more way we can write this program, that is using else if statements. So here is the code for writing with else if statements. You can note that this program reduces the indentation of the statements. In this case, every else is associated with its previous if. The last else goes to work only if all the conditions go to fail. Even in else if ladder, the last else is optional. Note that the else if clause is nothing different. It is just a way of rearranging the else with the if that follows it. Another place where logical operators are used is when we want to write programs for complicated logics that ultimately boil down to only two answers. For example, let's consider the following example. A company insures its drivers in the following cases. If the driver is married, if the driver is unmarried, male, and above 30 years of age, if the driver is unmarried, female, and above 25 years of age. In all the other cases, the driver is not insured. If the marital status, sex, and age of the driver are the inputs, write a program to determine whether the driver is to be insured or not. Hereafter, checking a complicated set of instructions, the final output of the program would be one of the two. Either the driver should be insured or the driver should not be insured. As mentioned above, since these are the only two outcomes, this program can be solved using logical operators. But before we do that, let us write a program that does not make use of logical operators. So here is a program which does not make use of logical operators. From the program, it is evident that we are required to match several ifs and elses and several pair of braces. In a more real life situation, there would be more conditions to check leading to the program creeping to the right. Let us now see how to avoid these problems by using logical operators. As mentioned above, in this example, we expect the answer to be either the driver is insured or the driver is not insured. If we list down all those cases in which the driver is insured, then they would be driver is married, driver is unmarried, male and above 30 years of age, driver is unmarried, female and above 25 years of age. Since all these three cases lead to the driver being insured, they can be combined together using and or operators as such. So here is the program which uses logical operators. In this program, it is important to note that the driver will be insured only if one of the conditions enclosed in parentheses evaluates to true. For the second pair of parentheses to evaluate to true, each condition in the parentheses separated by and must be evaluated to true. Even if one of the conditions in the second parenthesis evaluates to false, then the whole of the second parenthesis evaluates to false. The last two of the above arguments apply to the third pair of parentheses as well. Thus, we can conclude that the and or are useful in the following programming situations: when it is to be tested whether a value falls within a particular range or not, when after testing several conditions the outcome is only of the two answers. This problem is often called yes or no problem, okay? Next, going to the not operator. So far we have used only the logical operators and or. The third logical operator is the not operator, written as an exclamatory mark. This operator reverses the result of the expression it operates on. For example, if the expression evaluates to a non-zero value, then applying a not operator to it results into a zero. Vice versa, if the expression evaluates to 0, then applying a not operator to it makes it 1, a non-zero value. The final result after applying not operator, 0 or 1, is considered to be false or true respectively. The not operator is often used to reverse the logical value of a single variable, as in the expression if with exclamatory mark flag. This is another way of saying if flag is equal to 0. Does the not operator sound confusing? Avoid it if you want, as the same thing can be achieved without using the not operator. Hierarchy of operators. Since we have now added the logical operators to the list of operators we know, it is time to review these operators and their properties. This table here summarizes the operators we have seen so far. The higher the position of an operator in the table, the higher is the priority. So let's see. The highest priority goes to logical not, which is an exclamatory mark, and then the next priority goes to arithmetic and modulus, and then arithmetic, then relational. In relational, we have two. The first priority goes to less than, greater than, less than equal to, greater than equal to, and then goes to is it equal to or not equal to, and then goes to logical and then goes to logical or, and then assignment. Assignment. Please do remember that assignment of a value to a particular variable is done by a single is equal to, and comparing two variables or two values is done by double is equal to. So this picture summarizes the working of all the three logical operators. The three logical operators are not, and or. So let x and y be 0. Then not of x is 1, not of y is 1. X and y both are 0. X or y both are 0. If x is 0 and y is non-zero, not of x will be opposite of 0, that is 1. Not of y will be opposite of non-zero, that is 0. x and y both are 0, x or y both are 0, and so on. The conditional operators question mark and colon are sometimes called ternary operators since they take 3 arguments. In fact, they form a kind of foreshortened if, then, else. The general form is expression 1 question mark, expression 2 colon, expression 3. What this expression generally says is, if the expression 1 is true, that is, if the value is non-zero, then the value returned will be expression 2. Otherwise, the value returned will be expression 3. Let us understand this with the help of a few examples. This statement will store 3 in y if x is greater than 5. So basically, first we check if x is greater than y. If it is, then it will store 3 as y. If it's not greater than 5, then it will store 4 in y. Now let's just see this expression in a simpler way with an if statement. If x is greater than y is equal to 3, else y is equal to 4. It's very simple to understand it this way, but this is how it can also be written with conditional operators. Next, here 1 would be assigned to y if a is greater than equal to 65 and a is less than equal to 90, evaluates it true. Otherwise, 0 would be assigned. Basically, what this equation says is, or what this statement says is, if a is in the range of 65 to 90, including 65 and 90, then y would be assigned with the value of 1. If not, then y will be equal to 0. There is one point to be noted about the conditional operators. It is not necessary that the conditional operators should be used only for the arithmetic statements. So now let's revise what we have done in today's class. There are 3 ways of taking decisions in a program. First way is to use the if-else statement, second way is to use the conditional operators, and third way is to use the switch statement. The default scope of the if statement is only the next statement. So how to execute more than one statement? They must be written in a pair of braces. An if block need not always be associated with an else block. However, an else block is always associated with an if statement. If the outcome of an if-else ladder is only 1 or 2 answers, then the ladder should be replaced either with an else-if clause or by logical operators. And or are binary operators, whereas not is a unary operator. In C, every test expression is evaluated in terms of 0 and non-zero values. A 0 value is considered to be false and a non-zero value is considered to be true. Assignment statements used with conditional operators must be enclosed with a pair of parentheses. With this, I would like to conclude the class, giving you a few exercise questions for you to solve. So these are the exercise questions that I want you all to try and solve. Thank you.